Adding CI/CD to a legacy application by me, John Rasch. The primary goal for this presentation will be to identify areas in the build, deployment, and release processes that can be automated, and then that should give you a nice stepping stone in order for you to automate them. And I'll show a couple simple templates to outline how this automation could be accomplished with BuildMaster. So moving on, about me, I am the product director for Inedo, formerly software developer. I've been there for 10 years now. I started as a software developer and only recently this year was promoted to product director. I've been a software developer pretty much my whole professional career. So I got my background in like PHP, web development, moved on to .NET from there, and then moved on to Inedo, where obviously we build our products in using the .NET framework. So currently, I am responsible for release planning, release execution, and all of the essentially things above software that go on with release, like documentation, notifying key customers, that sort of thing. So in addition to that, I'm also responsible for managing this, the support system we have. So if you've ever submitted a ticket to Inedo and you've seen a response from John, that's me who you're talking to. Cool. So I will begin by using some definitions. The first being, what is an application? Because that's a pretty generic term. So I'll refer to it as a program or service commonly distributed as multiple deployable components, ultimately designed to interact with another application or end user. This can be realized as a feature or a component of another application, maybe a larger one, for example. It may or may not be maintained by a specialized team. So an example of this would be Facebook. Everyone's familiar with that. I personally don't use it, but I know it's a very ubiquitous application out there. Facebook consists of many applications. It has a wall where you make posts to and people can see all of your pictures and all that sort of thing. It has a messenger system, so it's basically chat. The chat and the wall are not really related at all. It has an event subsystem where you can schedule, say, your team's softball game or your next meetup group or something like that, and then invite people based on that. And I consider the mobile application also a separate component of this because it's a different interface to using the Facebook system. Each of these things are typically released on their own cycle, but there's a high probability it's in conjunction with a different component. So for example, you want to add the unread message count or something like that to the messenger system. Well, you also have to update the mobile app in order to implement that feature as well. So both of those are then deployed likely at the same time. So that being said, what is a legacy application? Every application is a legacy application. More specifically, an application that has gone to production and is still used by at least one person. So if there's an application out there that nobody uses, it's not really legacy. The actual definition I found was that an application that is considered to be unstable, outdated, obsolete, or otherwise incompatible with modern systems, but still delivers value for the business. So that goes back to every application. So now that we've defined applications, what is CI/CD? A lot of people are familiar with it. It's much like DevOps. It means a lot of different things to a lot of different people. Jenkins, for example, is a common answer I've heard when I ask people what CI/CD is. More generally, pipelines. So that's obviously a component of Jenkins. Containers is CI/CD. So building them, deploying containers, that's CI/CD. Or just scripts, which is pretty much in common with source code as it's just bytes or just text. So what is CI/CD really? It's made up of two components, obviously. Continuous integration, which is automating the process of creating and testing builds, and continuous delivery, which is automating the process of deploying said builds. So that In other words, automating the complete process from source control check-in to production deployment. So everything after the developer gets hands off with the code is CI/CD all the way through release. So let's talk about some of the benefits of CI/CD. Number one, instant feedback on builds. So what does instant feedback mean? Like, failed builds or automated tests are known immediately once you either check in source code if you have continuous integration configured automatically, or if an automated test fails. You could either get notifications for it, you could see it in the deployment or the build or deployment logs, and that sort of thing. Reduced risk, which I heard many times earlier, how that's really what drives changes in a business. They don't care what it costs, they just want the risk to be reduced. Failures are always going to happen, but when you follow CI/CD, you enable rollbacks and diagnostics are enabled, so you're able to go in and see exactly what failed. This also enables on-demand deployments if you separate your build and your deployment process into two separate pipelines. And in turn gives you instant feedback and also deployment logs. Fosters communication among teams is another benefit of CI/CD, because the build and release engineering teams are now in lockstep. We've heard many times, even I believe it was Jody was saying, they just get the build and then they take it and then send it through their deployment process using BuildMaster, for example. So now we have a hypothetical application. This example application, I'll refer to it as the Automotive Credit Payment Portal. Its major components are Com Plus service, which we've heard multiple times today, and that integrates with SAP for invoicing, because anything that integrates with SAP is legacy by default. A business-facing VB6 Windows Form application used for invoice report generation. A customer-facing web portal written in PHP. So why are those components not considered applications themselves? Well, by some definitions they are. As I mentioned, the word application has many definitions. Google's definition, for example, is a program or piece of software designed and written to fulfill a particular purpose of the user. In the Facebook example, each component only depends on user interaction through the UI. So when you're integrating with the wall, or when you're interacting with the wall, you're logging into Facebook and typing something in there. Contrasted with the Automotive Credit Payment Portal example, where the Com Plus service is useless without someone logging in and creating or making a payment or viewing their invoice history. And nobody knows which components need to be deployed together. This is a common issue with microservices, as we heard before with the whole dependency discussion we had. So for this example team I'm going to use, there's going to be a development team responsible for developing features and integrations for this portal. The release engineering team, which is responsible for the actual deployments, or SRE is the other common term we've heard. Infrastructure and ops team, which is responsible for provisioning servers and monitoring. The customer support team, which acts as a bridge between the customers and release engineering team and developers. So that's like the Bob or Milton from Office Space. And the sales team, end users of the VB6 reporting application. So on to build automation. So the existing build process for this Com Plus service, as we know, this is the one that integrates with SAP to generate invoices. It's written in C++, so we know we have to use some kind of Microsoft MS Build type compiler for it. It's rarely, if ever, updated. That's kind of a common thing when it comes to legacy. Built by, we'll refer to it as Bob on his desktop workstation, and nobody knows nor cares the precise steps for how he does it. Maybe he uses Visual Studio, maybe he uses Final Builder, doesn't matter. Bob usually runs the unit tests before rebuilding, but not always. It's not really a requirement, because again, the people that receive this built service don't care. And because this tool is rarely rebuilt, it is delivered via CD or USB. So another component, the VB6 reporting app, is built with an old version of Visual Studio on a server. Server is located on a desk near the development team. Now, I had not heard or seen Alex's talk before I came up with this, so it's actually quite amusing that this is a real thing. When necessary, the developer logs into the machine and creates a build in Visual Studio. And then they take the output, put it on a shared drive that the release engineering team can access. Then they notify the release engineering team that the build is ready to be deployed. So whether it be email or Slack, or even go over to the desk of the person responsible. The customer portal website, there isn't a build process for it. PHP files are just files on disk. These files are stored in some kind of source control repository, so we'll use Subversion because I didn't want to go all the way back to CVS. A developer sends an email to the release engineering team to export, telling them to export the latest code. And at their discretion, they may or may not run static analysis or unit tests, depending on the diff of the previous version. So how can we add CI to this? First, rewrite the entire VB6 application in Node.js and Electron, then rewrite the SAP integration as a REST microservice, migrate all the source code to GitLab, configure GitLab to build containers for all 3 components of this application, convince the business to spend large amounts of time, money, and resources to recreate the whole application that already exists, and then throw it away because it's not going to work. So how do we add it really? The key is to automate the process that you already have. Start by identifying the points of the build process that can be automated. Minimize risk by using side-by-side automation. So how does that work? Basically, you take the process you already have, automate it using a tool like BuildMaster or something similar, and then you could look at both components side by side to make sure that it actually works correctly. The key points to identify when doing CI are that build output should be captured into build artifacts. Regardless of the technical definition of build, there's more to it than just turning source code into an executable. Do not rely on Bob with all the institutional knowledge because he may or may not be there one day. He could be hit by a bus, he could retire, he could quit. As we've made it a point earlier, documentation for these processes is key. Any build server is a key component of infrastructure. Manual processes to alert teams are unreliable and untraceable to other teams. Build artifacts should be used. Immutable builds are the foundation of any repeatable low-risk deployment process. That's why you should use build artifacts. Build once, it enables build once and deploy often. It enables rollbacks. And common types of artifacts can be files or archives, which is just a zip file or a tar ball or something like that. Containers are actually an artifact of a build output. Universal packages and images for physical mediums, that could include VHDs even, but I was thinking more ISO. Can be created manually and updated or uploaded to a CI/CD server. So we've heard this example before as well. So some build automation anti-patterns to be aware of. While these cannot always be avoided, they're worth keeping in mind during the automation process. Not using artifacts is a huge one. Pulling things directly out of source control and then putting them on disk is just, it's very error prone and very risky. Capturing diffs instead of the full build output. So like kind of someone mentioned doing partial deployments, how they can collide over each other. Definitely don't want to be doing that. Environment branching, there are reasons to do that if like you want to do a smoke test of a dev build or something, you can, and it takes maybe 1/10 the time. You could do something like this, but what you should try to avoid is building on a dev branch and then building on a separate QA branch and then going straight to QA, skipping the first part of the pipeline. which is rebuilding in a future stage. And then omitting or ignoring versioning. It's so simple now, you could just include another file with your build output that indicates what version it is, and of course you could stamp a binary. That's probably the easiest way to do it. So coincidentally, in BuildMaster, when you generate a new application, you see this 4-section deployment plan, or build plan in this case. Typically follows these patterns of getting source code from somewhere, fetching the code changes, compiling the project if it's actually a project that requires compilation. So you're running a familiar tool such as MS Build or Maven or Make, whatever, in order to create the binaries. Running tests on those binaries, which includes unit tests, static analysis, and then you could even capture reports from that. And then ultimately capturing the artifact so you can deploy it in a future pipeline stage. So on to the CD half. So in this existing deployment process for the COM Plus service, the release engineer receives a CD or USB from Bob. It really just depends on what's on his desk. If he grabs a CD, or if he grabs a USB. Asks the infrastructure team which server to update the service on. Unregister the existing COM service. Copy paste the build output over remote desktop. Register the service again. For the VB6 reporting application, the release engineer browses to a drop folder. They select the newest build by ordering by modified date or something like that. Post the newest build output to SharePoint. Notifies the sales team that they should download the latest version. The existing deployment process for the customer portal website. The release engineer does a diff and subversion for the files that changed since the previous version in trunk. The release engineer determines the files that have changed based on the diff, creates a folder structure with those changed files, likely on his desktop, stops the existing website, copies them over remote desktop on top of the existing site, so it only overwrites the ones that have changed, and then restarts the website. So how do we add CD to a process like that? Rewrite the whole VB6 application in Node.js and Electron, rewrite the SAP integration as a REST microservice, migrate everything to GitLab, convert it to containers, and convince the business to spend large amounts of time and money and resources to recreate an application that already exists, and then throw it away because nothing works. So how do we really add CD? Same keys as adding CI, actually. Automate the process that you already have. Start by identifying the points of the deployment process that can be automated. And minimize risk by side-by-side automation. So what are some of these points? Break down the deployment process of application components into repeatable high-level operations. Determine server and/or environment targets, so that would include the workstation on Bob's desk. And common operations include starting or stopping services, copying or deploying files, and notifying key stakeholders before or after deployment. And that could be via email, via Slack these days. That seems to be the most common. So what are some common deployment automation anti-patterns that you should try to avoid? Number one being the piecemeal or partial diff-based deployments, because this makes rollbacks extremely difficult unless you were to take a backup first. So by deploying a full artifact, just like, again, Jody mentioned, you could just redeploy the previous build, and boom, you're done. Oh, before I go forward with that, another common reason people do the piecemeal deployments is for bandwidth reasons. So like say the full artifact is, a gigabyte or something, you only want to move one file or two files. Let the automation tool that you're using handle that sort of thing instead. So another common anti-pattern is the remote desktop deployment or accessing production servers directly, which obviously if you're an ops person, you're allowed to do that, but you should really not have developers logging in and changing files on production servers. Another major anti-pattern is an undocumented deployment process. So even in non-legacy situations, if only one person knows how to deploy to Kubernetes, for example, on the team, that person may as well be Bob. Just with instead of Kubernetes, it's a desktop machine in their cubicle. So again, not by coincidence, the default template plan when you create a new application in BuildMaster that is generated for you follows these main 4 steps here. Stopping all services, whether it's websites, container services, or clusters in the case of Kubernetes. Deploy the artifact that you've captured in a previous stage from the build plan to whatever service, container, or cloud service. Configuration files I hadn't mentioned before, but that would be like the equivalent of web config or anything of that sort. Properties files in Java that controls how the application behaves in a different environment or maybe contains secrets or something like that. And then start services that were stopped at the beginning. So this, while there's downtime here, it's very minimal because it's usually very quick. So one of the final pieces that's not talked about as often is process automation. So what am I talking about? This sits a layer above build and deployment automation. It bridges the gap between the non-technical and technical processes involved in the application lifecycle. So what does that mean, bridges the gap? Well, once automated, for example, you could run this deployment plan against these servers. Who decides what those servers are or when they're allowed? So these things are, that is a higher level above the CI/CD process itself. It encompasses the release lifecycle, stakeholder interactions, and methods of communication. So all of that stuff is involved in process automation. So for this hypothetical example, releases are planned based on product issues, typically initiated from compliance issues reported by business analysts or SAP interface changes. One of those two things would commonly cause a new release for this legacy app. Business analysts enter the issues into an Excel sheet stored in SharePoint. The manager responsible for overseeing the payment portal routinely monitors the Excel sheet for new issues. And issues get delegated to the appropriate teams depending on the application component. So as I mentioned in that previous slide, one of the main components that you need to identify when trying to automate a legacy process, issue tracking is number 1, which I'll talk about again on the next slide. User approvals and sign-offs. So that's more than just, Bob says the build looks good, go ahead and move it to advance it to the next stage. It should be something semantic or compliance related in nature, like SOX, for example, requires 2 different people to do the build and deploy, for example, also requires a multi-engineer approval. So you could put that directly into your CD system, and then those required people can go ahead and check that off. Deployment windows, you can set specific times or days, or a combination of both, where people can actually do deployments to certain environments. And with that comes gates and automated checks, including things such as all issues are closed before going to staging. All unit tests are passed before going to QA, because maybe sometimes you don't care that that one unit test failed or something, but maybe you do. Did the build originate from master branch? So with the introduction more recently of Git flow, you don't want a dev branch going all the way to production or something like that. So you can make sure to put that directly into your automated CI/CD process to avoid it. So going back to issue tracking, an issue represents a distinct change to software behavior and may include bug fixes or new features. And in legacy applications, it's probably not the latter. But like I said, sometimes there's compliance changes that require you to make those or to add those new features. Issues should be documented and their status visible to stakeholders and development teams alike. And these issues should be associated with the release, not simply just a list of tasks that are marked complete when the code is committed. So, final thoughts. Nobody sets out to write a legacy application. I know we've heard many times today about the monolith, how that comes to be. Nobody ever sets out to write a monolith. Same case with the legacy application. The Node.js applications being developed, containerized, and deployed to Kubernetes right now will eventually also become legacy, just like Common was back in the 90s. Identify points or milestones in the software delivery process that can be automated and incrementally automate them for the build, deployment, and release processes. By focusing on automating the process, automation can be applied to any technology. So if you're focused on the process itself, it doesn't matter whether you're in Subversion, doesn't matter whether you're using Git, CVS, doesn't matter what issue tracker you use as long as you're tracking issues. Doesn't matter what platform you're running on, all of those things. Ensuring the process can adapt in the face of inevitable change will prevent the process from becoming legacy as well. So if you're very rigid on your process and it's in a place where it's very difficult to change it, that's going to become legacy just like the application itself. So hopefully this information will help you with the legacy application that you're building right now. And thank you.
Can I ask a two-part question?
Absolutely.
Can you do me a favor and go back to the slide about, I guess it's sort of the nihilistic, how will you add a CD process to the application, and it was like converted to Node.js and get it to GitLab, and then you'll never use it.
Oh, that one?
So yeah, we hear about organizations making the decision to go this route. As a non-engineer, I think it might be because people like to build stuff.
Certainly.
What?
Certainly, yeah, that's one reason.
So, and I want to combine two things. You were at the Birds of a Feather kind of collaboration group over there.
I was.
Things like these waste of time are probably avoided by groups communicating better, I would think, to come to the realization that there's a way to add these CI/CD processes quite a bit more simply, like the way you've outlined it here. Can you maybe tell me a little bit about kind of what you guys were discussing at the Birds of a Feather, and sort of maybe just kind of try to combine this idea of like, how can collaborative communication avoid these types of situations we hear about so often? If you can, I mean.
Right. It's really about trade-offs. Yeah, this is kind of a joke here because it's a legacy application. It's not something that gets changed very often. Certainly there are times where rewriting an application is the correct thing to do. Who knows? It's just that you have to balance time, resources, all of those typical things in order to do so. But the key thing we focused on in that Birds of a Feather was communication and documentation. So if Bob is his own silo, like they said, the release team doesn't care how Bob gets them the build, as long as they get the team the build, so he's able to take it and deploy it at that point.
Okay. Cool. Okay.
That's it. Nice minute and a half an hour. All right.